Okay, so I think guys, we are live. So can you confirm in the chat if you can hear me, if you can see me, then I'm audible or not? Please do let me know, guys. Hello, hello. Okay, great. So let's start with the session. I think we can wait for more 2 minutes and then we'll start with the session. So we were implementing our deep learning project, and I took actually 2 sessions. So in the first session, I given you the complete introduction of the deep learning project, and in the second session, I talked about the data ingestion pipeline. So I believe, guys, you are attending my session. Actually, last two session was taken by the Buppy. So in those session, Buppy has explained you the concept of the transformation, data transformation, and he has explained you about the he has explained you about the model trainer and all, right? So two component was taken by the Buppy and two classes was taken by me. So don't worry, I can give you the quick walkthrough, and then within 5 minutes we'll start with the session. So first of all, let me give you the quick overview of the entire project, and then today in today's class I will talk about the this Jupyter notebook. So in that Jupyter notebook itself, we'll try to perform all those experiment whatever you have done so far, so you will get clear cut idea, and we'll see that how we can write the evaluation matrices also. So we are done with our model training, right? Now we'll see that how we can write the evaluation matrices, and then if time will permit, then I will show you that how you can use the bento ml for pushing your model. Okay, so there are a couple of things which we need to discuss. Okay, so for completing this pipeline and all, and then after I will come to the deployment and all. So fine, first of all, let me give you the quick walkthrough that what all thing we have done so far, and after that I will come to today's agenda. So here you can check with the playlist. Inside the playlist already we have updated each and everything. So we are maintaining one playlist. The playlist name is Deep Learning End-to-End Project. Just click on this playlist, and here you will find out all 4 classes. Okay, so not four actually. There is yeah, 4 classes. Today is the 5th one. Now 2 classes was taken by me. Were taken by me, and this one, this transformation and this model training actually, it was taken by the Buppy. So in these 2 classes, in last 2 classes, we have talked about the transformation and model training, right? So if you don't know about the transformation and model training, apart from this ingestion, if you haven't seen, guys, so you can complete from here. And one more thing, so we have attached one dashboard as well. So once you will go and check with the like a description, so there you will find out the dashboard. So whatever resources and all we have already uploaded over here regarding the project, even the entire project is available over here inside the resource section. You can directly download from there. Now, let me show you the dashboard as also. Let me give you the quick walkthrough, and then I will start with the session. So first of all, guys, you need to log in. So here you can see I'm logged in. Now, once I will click on this, go to the code. So here I will find out my dashboard. So, okay, video is not is still there. Why it is not there? Fine. So I will check with my team. Don't worry. If it is not there, it will be there along with the project and all. Now, guys, see here all 4 videos. And now let's start with the 5th one. So in today's class, we are going to see that how we can perform the evaluation of the trained model. Now, before that, I will give you the quick walkthrough of the entire project, and I will give you the project as well, that where you will find out this entire code and all. So initially, in my previous classes, in my first and second classes, I was maintaining one GitHub. So I kept each and every code, each and every line of code over there itself. So if you will check with my GitHub, guys, so there basically you will find out the code related to the ingestion only. Now, what about the model training and the transformation? So I think Buppy has already shared his own GitHub. So inside this particular GitHub, this is not my GitHub, this is Buppy's GitHub. So you can search about this GitHub repository, ENT Buppy, lung X-ray classification. You will get it. Okay, if you don't have it, don't worry, I will give it to you. Now, here basically in this particular GitHub, I was maintaining the entire code. Let me show you my GitHub and let me show you all the codes and all. So this one, deep learning project. Now, once I will open it, guys. So here you will find out this is the entire code. Now, if you will look into this code now inside this X-ray itself, so there I just written one component, this data ingestion component, and rest of the component basically I haven't coded transformation and all because it was taken by the Buppy. So it is available in his GitHub. Now, what I'm doing here, I'm updating my GitHub and I'm giving it to you so that you can also run inside your system. And then I will give you the quick walkthrough of the entire code, whatever we have done so far, and then after that I will write the code for the evaluation and all. So let's start, guys. I think it's already 2:37 and most of the people has joined now. So yes, finally we can start with the session. So first of all, guys, what I can do here, I can update my entire code. Here it is already available in my local system. So let me show you where it is. So this one, guys. So in my VS Code, I already opened it. I'm using the VS Code only. Now I'm not using the Neurolab because as I told you that I was facing some challenges while I was connecting with my AWS and all. So here I was using this local setup and all. If you don't know about the local setup, you can visit the previous sessions. There I have shown you that how to do the end-to-end setup for the projects. Okay. Now let's start with this like project and also here basically I have written one ipynb file also. Inside the ipynb file, I written entire code related to the training and the evaluation and all. So I think Buppy has directly shown you this transformation and this training and all. But don't worry, what I will do here, I will give you the quick walkthrough, right? Quick walkthrough of the entire code so that you will get a clear cut understanding, and then we'll go with for the next component. Now, here, guys, the first thing which I would like to tell you. So, I hope you have this data ingestion, and if you are following this series, then definitely you have this transformation and the training also. But if you don't have it, so what I can do here, I can push it inside my GitHub, and I will share inside the chat so that you can clone it and you can run it inside your system as well. So just allow me a minute. I'm doing it in front of you only. So the command is git remote -v, and yes, I already connected with my GitHub. Here you can see I'm getting the origin. So this is my origin, means I'm already connected with my GitHub. Now what I'm doing here, so here actually I'm passing this code. I'm pushing this code, right? So first of all, let me mention this artifact into this git ignore file because I don't want to push this artifact to my GitHub. Now here I'm mentioning this artifact folder, and okay, just a second. Artifact, artifacts. Okay, it is perfect now. Now let me do one more thing here. Let me mention the log as well. I don't want to push the log. So whatever thing I don't want to track or I don't want to push, I can simply mention inside the git ignore. So I mentioned my log folder, I mentioned my artifact folder. Now it's time to push my changes. So first of all, let me commit it. So git add dot. Okay, great. Now let me write here git commit -m, and here uh, updated code. So guys, I have added all the changes, right? See, I added and I committed also. Now let me push it. So git push origin main. So here I am pushing the changes and see I am able to push it. Okay, perfect. Now let me show you. So once I will open my GitHub, now here if I will open this data transformation, so you will find out the entire code for the transformation, and here you will find out the entire code for the model training also. Now two component was remaining. So the first one was the model evaluation. So in today's class we'll see that how we can write the code for the model evaluation, and after that, after model evaluation, there is one more component, that is what, there is a model pusher. So we'll see that how we can utilize this model pusher. Okay, and I will show you that how you can write it down the script for the Vento ML, and how you can push the and how you can push your model by using the Bento ML, how you can serve it. So we'll see that in a live class itself, but not in today's session, in upcoming week. Got it? Great. Now here model pusher is there, and model evaluation is there. So I think in the model evaluation also I have written a code. Yes, you can see we have the code in the model evaluation also, but this model pusher is empty as of now. Don't worry, I will write the code in the model pusher also in my next class. Now you will find out guys the endpoint and all. So here this main.py is nothing, it's my endpoint. So everything I'm running from there itself means I define one training pipeline basically, and I'm handling that by using this main.py. So here I've imported this training pipeline, and then I defined the method and I'm executing it from here itself. So the entire training pipeline basically I'm executing from this main.py. So this main.py is nothing, it's my endpoint. Okay, I've defined this endpoint over here. Now I hope you know about this particular thing, because already we have discussed in a live class. Now, first of all, let me give you this GitHub link so that you can download this updated code. So just wait, guys. I am giving you this particular link inside the chat itself, so that everyone can download it. Just a second. Okay, I hope you got the link. Please do confirm, guys, if you got the link. Then did you get it? Did you get the link of the code, the updated code? If you can write it on the chat, so I think that would be great. Please do let me know, guys, if you got the link, and then we'll proceed with the further discussion. Great, Ravi Kumar. So I believe everyone got this particular link. So please do let me know if you have any doubt that how to run it, how to execute it. If you joined first time, that definitely you must be having that doubt, sir, how to clone it, how to run it, how to like run this main.py and all. So it is very, very simple. Here actually I think we have given you the entire like a process and all. So first you need to create an environment, and after creating an environment you just need to install the required.txt file. And then here guys, this is for the data ingestion, because we are ingesting a data from the AWS only. So we are like assuming that my data is available in some cloud repository. So my data is available in S3, and from there itself we are going to ingest it. So this is the setup for the data ingestion. Right now here we have given you all the steps and all. Now just wait, let me mention it in my GitHub also, and let me give it to you. Okay, so I'm going to copy it from here, each and everything, and just a second guys, I'm giving to you. So here is this one. Now git add dot. Okay, perfect. Now Great. Now let me push the changes. So git push origin main. Mhm. Okay, great. So now let's start with the class. So I believe, guys, it is there. Just check with my README. No, it is not there. I think I committed or not here. So git commit hyphen m modifier readme git add dot. Just a second, guys. Let me add it. So git. Yeah, now I think it's perfect. Git commit code up, readme updated. Readme updated. Okay. Yeah, now it's perfect. So git push origin. Yeah, now it is perfect. So here, if I will refresh it, so you will find out the entire commands and all inside the readme itself. This one. So you can go and check. You can copy it. Don't worry, I will modify it because I will have to put the special like symbol and all because it's a markdown file. But yeah, here this is the command conda create python in a conda create hyphen n lungs python is equal to 3.8. This is for the environment. Now here it is for the like conda activate. This command is for activating the environment. This command pip install hyphen r requirement.txt, it is for installing the requirement, right? Don't worry, I will segregate it because here I will have to mention some specific notation because it is markdown file. So let's start. Like begin with the discussion and all. Now here in this project, you can see we have the different components, right? Now inside the component, actually, you will find out. Let me show you the component. So we already kept each and everything inside this component folder. Now we have this data ingestion, data transformation, data evaluation, data model training, right? On this model pusher. Now, first of all, guys, let me give you the quick overview or quick walkthrough, basically what we are doing over here. So I can write each and everything here on the blackboard itself, and so that you will get the clear cut idea. Now, for that, guys, just a wait. Let me open my. mm, okay, let me open my blackboard. Yeah. So guys, we were talking about the different components and all. So already we have coded a couple of components. So the first component which we have coded, that was the data ingestion, right? And then guys, I will come to the like IP-binary file. So there I will execute each and every experiment so that you will get the enough amount of idea regarding this particular component. And finally, we'll come to the evaluation part. So how we can write the evaluation means if we have test data, if we have a validation data, then how we can write the like different matrices and all. Okay, we can write the code for the different matrices and we can evaluate the model, already saved model. So here the first component was the data ingestion. Now from where we were ingesting the data, tell me. If we are talking about this data ingestion, so I only did the code for the data ingestion. So here we were ingesting the data from the S3. Okay, so from S3, Amazon S3, we were ingesting a data, and we were where we were keeping it. So we were keeping the data in our artifact. So here in the local workspace itself, we are creating one artifact folder. Artifact is nothing actually; it's the output of the component. So we are getting an output from the component, and that is called, that is nothing, that is the artifact. So the specific artifact folder itself, we are keeping the data only. So we are getting the data from the S3 and we are keeping inside the artifact. So guys, here we are maintaining all the versions and all. So we are maintaining all the versions, like the we are doing a pipeline versioning over here. If you will look into the artifact folder, I will just I will show you after this one. So there you will there you will see that we are like creating a folder based on the timestamp. So as many as time will run the pipeline na. So as that time only will be at that much time only we will get a we will get a folder inside the artifact only, and based on the time stamp, right? So here what we are doing, so we are doing a pipeline versioning. Again, don't worry if you don't know about it, I will show you. But if you have run the pipeline, okay, if you have executed that pipeline, definitely you must be aware about it. Now the second thing, after this ingestion and all, so we were doing the transformation, data transformation. Now inside the transformation, so there basically you were doing a different pre-processing technique or different augmentation technique, because it's a like data related to the images only. So if we have like a tabular data, so for that the feature engineering or the transformation technique is different. If we are using the image data, so for that the transformation and the feature engineering technique is different. So here we are doing a transformation according to that particular data, and we are using a image data, so definitely we are doing a transformation augmentation according to the image data only. So I will show you, I will give you the quick recap of it so that you will be getting in a better way. Then the third thing after the transformation, so model training was there. So model training means, so first I will transform the data according to the requirement, and then only I will pass the data to my models. So here on the next step was the model training. So next step was the model training. Now after the model training, guys, so what I will do, so here we'll do the model evaluation. So here after the training, actually evaluation, I will do the model evaluation. Now this model evaluation part is remaining, this one. So we'll see that how we can evaluate the model. So each and everything we'll see over here related to the evaluation and all. And then the last step is called here in this particular pipeline, in this component, that is called model pusher, right? So model pusher is also there. So here we'll see this model pusher in our next class. So how we can push this particular model by using the Bento ML. So that's going to be a primary agenda, okay, for the upcoming session for the next class, and we'll try to understand the basics of the Bento ML. Now why I'm including this different ML ops tools and all, because already I told you that this end-to-end project, actually it is we are implementing it with the MLOps methodology only, and whatever like tools and technologies is there related to the MLOps, machine learning and operation, definitely we are going to use all those tools and technology over here inside the project, right, for maintaining this pipeline. And the same thing actually I did in my previous project also, in my machine learning project also. So throughout the pipeline, whatever MLOps tools was required, right, related to the different component, whether it's a data versioning, whether it's a code versioning, or any other thing, right? So I did it, right? If you don't know about it, you can go and check my playlist. I already kept all the I already kept the like videos and the code inside the playlist itself, inside the iNeuron YouTube playlist. Fine. So this thing is clear now. Here this two steps is remaining, evaluation and pusher. Now in the data transformation, actually we are doing a different like transformation transformation related to this image data. And then in this model training, actually we are training our model, so we are using the CNN network, convolution neural network. I think already we have talked about it already, like in the code you have seen in the previous classes. Now here actually for creating the CNN and all, right, we are using the Python, sorry, PyTorch. We are using PyTorch. Now PyTorch, what is a PyTorch, guys? So PyTorch is nothing, it's a module in Python, for the computation and all, or for writing. Actually it's a framework, it's a complete framework where you will find out already defined rule, like predefined like rules and all, okay. So and it's a computation framework which we can use for creating a neural network or for the different type of computation. Okay, so here we are using this PyTorch for writing this convolution neural network. Now data ingestion, data transformation, model training, and this thing is already clear. Now what was the flow, right? If you were writing the code, so yesterday also we have written a code, and the like day before yesterday. Okay, now what was the flow of the code? So here the very first thing, the very important file was the, tell me, was the component only, the main component. So we were writing each and everything around that component only. So instead of writing like this, what I can do, I can show you. each and everything here itself. So let's say this is what, this is my component. This is my one component. Let's say this is nothing. This is my data ingestion component. So this is my data ingestion. So data ingestion component. Now, related to this component, there were so many things. The first thing was the configuration. So here we were having the data configuration. So here I was having the data configuration. The second thing actually, which we were having over here, that was the artifact. So the output of the component was nothing. It was the artifact. We are collecting inside the artifact itself. So here the next thing was the this data artifact and all, or artifact will be a will be a find this artifact. Okay, this is going to be an artifact. Okay, now guys, this artifact is going to be a useful term over here because we are getting an output from the component, and that we are going to save inside the artifact folder, right? So configuration is there and artifact is there. Now apart from this one, guys, related to this particular component, we are having one more thing, that was the constant, right? So whatever variable was there related to this component, so we were saving each and everything inside this constant folder, right? In the constant actually, in the constant itself, we have created one training pipeline folder, and inside the training pipeline folder, the init was there, right? And there we were defining all the constant. So we are having the constant is nothing, it's a variable, whatever variable is there now, right? So we are defining all the variable inside this constant, whatever variable is required for this component. Okay, for any component. Here I am taking an example of this data ingestion. Got it? Now here we have this data configuration and we have the artifact. Now here this is the component and this is the constant. Now every component actually, so where we were writing where we were assembling all the component. Tell me where we were connecting all the component in the training, in the pipeline itself. Okay, so we are having one pipeline file, so one pipeline, and inside the pipeline actually what we were doing, tell me, we were connecting all the components. So whatever component is there, like data ingestion, data data transformation, model training, model evaluation, model process, each and every component we were connecting over here. So inside the training pipeline, so inside the pipeline actually, the we were having one pipeline. The name was the training pipeline. Okay, training pipeline. I hope this thing is clear to all of you, that what we were doing. So configuration was there, artifact was there, constant was there, and data ingestion and all was there. Now we are having few more few more file basically. So let me write down those name here. So the next file was the logger and the exception. So regarding every component, what I will do, tell me, I will create one logger and the exception. And throughout this project, throughout this pipeline, or throughout the execution actually, I will use this logger and this exception. A logger for logging the information, for collecting the information, okay, for collecting a metadata, that what is happening at what particular time. And here this exception is nothing, for handling the exception, means whatever exception and all we are getting at the runtime now. Okay, so for handling that, we have written this exception.py. So logger was there, exception was there, and this is my component constant for the variable and all, data config, artifact, and here we were having the pipeline folder, and inside that we are connecting each and every like a component. Okay, so this was the entire flow. I hope you are able to get it. Now next thing, what is the next thing here? So first of all, let me share the screen, and here guys, you can see this is the entire code. So I hope whatever I have explained you, that part is clear to all of you. Yes or no? So guide me end-to-end project for showing the final year project. Ashish, you can mention the same project. You can take the same project and you can mention it. Okay, inside your resume. Sir, where we can find the recording of all the past videos. So I think it is already updated. Okay, wait, let me confirm with my team. I think I will show you that where you can find out. Until what you can do, you can check with the iNeuron YouTube channel only. So here in the YouTube channel itself, you will find out all the recording, and the GitHub link I already share with all of you. So there, actually from there itself, you can download the code. Got it? Sapna was asking. So Sapna, I hope you got your answer. Okay, great. Now let's start with the next thing. So I explain you the flow, the complete flow. Now let me tell you the experiment over here. So basically I created one notebook, and inside this notebook actually I kept each and everything. And definitely with this particular notebook you will be able to revise your all the thing whatever you have done so far, right? Everything you can understand by using this notebook. We haven't implemented this thing in between, so directly we have written the code inside the component only related to the training or the transformation, anything, right? But here guys, let's try to revise it by using this particular notebook. So you will get like a good hands-on on top of this practical. And here on top of this project, and this is the like I would say this is the mandatory one. So whenever you are creating any project, so first try to run all the experiment, all the code inside the IP-9B. So it's always going to be a good practice, so that you will get a good exposure of your code if you're a beginner in that case. So that's why I'm writing it over here. So first of all, guys, you can see I've imported different libraries over here. So the same type of library I have imported in the model trainer, in the transformer, and in the ingestion and all. Now, if you will look into the architecture, guys, so here is a complete architecture. Now, let me show you one more time. I think I drawn it. This one. So related to the single component, data ingestion component is there. It can be data transformation. It can be model trainer, any component. So here, guys, related to this component, this is the complete configuration. Now here actually this is the complete configuration, but it is related to the modular coding. It is related to the modular coding whenever we are running any sort of a pipeline. So this all the thing is going to be executed. Now here, why we are writing this configuration here, artifact in artifact here, constant here, why we are not writing any everything in a single file? Because it's going to be a messy. Okay, it's going to be a lot like it is going to, it will create a lots of confusion. So that's why we are not going to write everything in a single file. We are going to segregate the task in a different file. So it's going to be a easy, right? In a bigger project in an industry actually. So we work like this only. We never write each and everything in a single file. We always create a we always write a different like a different logics and all, and a different file. So if it is going to, if we are going to write in a single file itself, so it's going to be a, it's going to be create a lot of confusion and all. So that's why we segregate the task only. Now here let's try to execute that ip-binary file, and let's try to understand that what we have inside this project and how the training is happening. And here actually in this particular file I written the code for the PyTorch as well, for the training and all, so that you will get the clear cut idea, even though we have inside the model.trainer. But yeah, let's try to execute over here. So first of all, guys, what I'm doing here, I'm going to import the library. And one more thing, if you don't have this thing, please try to download it from the GitHub itself. I already pinged in the chat, and I hope you are able to see over the screen as well. So this project is available in my GitHub, Sunny Savita 10, and please check out the link. Please try to click on that and try to download this particular notebook and the entire project. Do it, guys, fast. I'm giving you 1 minute of time until you can do it, and then we'll start with the execution. Yes, Ashish. So basics of the data structure is required everywhere. So if you are going for any interview, so it can be as a filter criteria. They can use it, this data structure and algorithm in the beginning of the interview. Basically, they can give you a couple of tasks. They can ask you some sort of a uh, some sort of a concept and all, and they can give you some codes and all, right, for writing in a like live interview and all. So yes, data structure, the basics of the data structure is required. Okay, so now let's try to execute this code. the code, whatever I have written inside this particular IPYNB. So first of all, see, I have imported different libraries over here. So here I'm using this PyTorch for creating the neural network. Now, apart from this PyTorch, you will find out some other libraries as well. So first of all, let me segregate those things, and then you will get the clear-cut understanding. So here I'm going to segregate it from here itself. So just a second. Let me create a new code. Now here I have written all the library related to the torch only. So here we are using the different module or different like methods and the classes from the PyTorch. So the first one is, see, neural network. This is for the data loader. This is the for creating a functional pipeline. They are actually, we are having two type of pipeline. So first is called functional and second is called sequential. So here we are creating a functional pipeline. Now, from the torch vision itself, we are going to import this data set, transformation models and all. Now, here is what step LR, right? So for defining the learning rate and all, we are using this particular method. Once I will use it, then definitely you will get the clear-cut idea. Now, for defining a summary of the entire model, we are using this summary. So once I will run it now, the entire one, then definitely you will get it. So here, first of all, let me import this thing. So see, it is working fine for me. And here you can see in the second cell, I have couple of other libraries like OS, NumPy, okay, CV2, Matplotlib. From the Matplotlib, we are like implementing this. Sorry, we are using this pyplot, right? And then MP image and this PIL image, IPython display and all. And here, what I can do, I can keep it in a new line. So just a second. Let me keep it inside the new line, and now it is perfect. So see guys, we are able to execute this thing, this two cell. Now this TQDM is what? TQDM is for getting the progress bar. So if you want to get a progress bar, so for that actually we use this TQDM. Now here what I'm doing, I'm changing my directory. So why I'm changing the directory over here? So that I can get the data, I can collect the data. Now where my data is available, so I told you that I'm fetching the data from the S3. From where? Tell me. I'm fetching the data from the S3 bucket. So my data is available in the S3, and whenever I will run the data ingestion component, so it will take the data from the S3 and it will keep inside the artifact folder. So just look into the artifact folder. So here in the artifact folder, you will find out we have a several folder, and each and every folder actually it don't have any specific name, right? So the name itself is the date and time. So here basically it is showing to me that okay, so at that particular date and time, at this particular time, on this date, you have executed this pipeline. So here we are maintaining, right, all the like versions of the pipeline. So as many as time I will execute this pipeline. So like as many as time, the new folder will be created over here, and this folder will be having the each and every information related to the execution. So let me show you. So here, if I will click on this one, 2/9/24, and this is the timing, 1 okay, so here I think it is 13:02. Yes, so I have executed this pipeline at this particular time. Now at 1 o'clock around. So now here you can see inside this one I have two things. First is training and the testing. I have ingested the data. Now what I did after that, I written few more components. Okay, so at this time you can see. So I written the data transformation. Then I written this model training. Now you will see the artifact related to all the component, all the other component. First, I was just getting with this regarding this data ingestion. Now in the next one, see, I have written like other component also in this at this particular time. So here at 1 o'clock, so you can see around 1 o'clock I was getting this thing, right? So only the data. Then after half an hour around, so at 1:28 I have written few more components. So here this is the like output related to data ingestion, this is the output related to data transformation, and this is the output related to the model training. Got it, guys? Yes or no? So here after like 30 minutes, sorry, after the 10 minutes, again I ran this particular pipeline, and here you can see the output from this particular timestamp, right? So from this timestamp, here is the output. So the output related to data ingestion, the output related to data transformation, and the output related to the model, sorry, data model training basically. I hope this is clear. Now, what is the meaning of the pipeline versioning? So we are doing it without using this ML flow, without using this DVC and all. Okay, by writing a simplest code, we are able to perform this pipeline versioning. I hope this is clear. This is getting clear to all of you now. Where I kept my data. So I kept my data to the S3. My data is available over the S3. Whenever I'm executing the data ingestion pipeline, so as an output, okay, as an artifact, I'm getting this data. Here you can see this one. So from here itself, I am going to fetch my data. So here, that's why I written this particular location. I'm changing the directory os.csdir. Why we use it? Why we use this method os.csdir? Actually, we use this method for changing the directory, right? So let's say we are in this directory. Currently, we are in this directory, deep learning. If you want to change the directory, so for that we use this os.csdir. So here I'm saying os.csdir. Now here I'm mentioning the path. So now what I'm doing, now I'm changing the directory to this particular directory. Means I want to ingest I want to get a data, and my data, where my data is available, my data is available inside this data ingestion folder. Inside the data ingestion, we have the folder name is data. Inside the data, actually you will find out this train data and the training data. Now this is the data ingestion folder. See, data is folder is here, train data and the test data. So everything I'm going to keep inside the, so every so here this is nothing, this is the artifact which we are getting. Now how we are getting it, what type of code we have written for getting this artifact and all. So everything we have tried to explain you in our previous session. So if you don't know about it, so please go and check with the previous session. You will get the clear cut idea that how this is happening, why this is happening. Now okay, it is fine. So you got to know about the data ingestion. So from here itself, from this particular folder, we are getting the data. Now I change the directory. Now if I will run this command os.get cwd, so I will get it that currently in which directory I am. So for checking the current directory, so I can execute this command os.get cwd. So you can see, guys, I am into this particular directory as of now. I am into this particular directory as of now, right? Means here you can see physically I'm in this directory, deep learning project, but virtually I'm pointing that particular directory. So here this os.cs directory, actually we are using it for performing that thing. So for changing the directory, right? But physically I'm in this directory here, but virtually actually I'm changing my directory, means I'm pointing out to that directory. Whatever code and all I will run it now, so the resources, the files and all, I am fetching from that directory only. I hope this is clear now. CSDIR is clear, and here this get CW is clear. Now what I'm doing, I'm keeping this path inside this variable. What is my variable name? My variable name is data underscore path, because from here only I want to get my data. From here only I want to read my data. For what? Tell me. For the transformation, for the model training, for the evaluation. Okay. Now here I'm keeping this path inside this data underscore path. So once I will run it, guys, here you can see I'm able to get it. I'm able to collect this path inside this data underscore path. I hope till here everything is fine. And I believe, guys, you are getting it also. Tell me. Yes, if you are watching to me, if you are listening to me, then please do let me know in the chat that everything is going in a like sequence and everything is getting clear. So can I get quick thumbs up or something? Tell me, guys, fast, so that I will proceed with the further code. And this is going to be a quick revision, a quick recap, or here we are running the entire experiment and all inside the IP/NB only. Already you have written inside the pipeline. So it's a reverse learning. Okay. Tell me, guys, if you can, if I can get the quick thumbs up or quick yes or no in the chat. So that's going to be great. MLOps in Hindi कब start करेंगे sir? Soon will start, Kashif. So as of now, I planned for this deep learning project. Now in near future, in upcoming future, actually, we'll start with the MLOps Hindi as well on the Hindi iNeuron channel. I think something is going on over there. You can check. Like we are teaching you the data analytics related project. We are teaching you the Python and all. So you can go and check the iNeuron Hindi channel. So perfect, fine. And I hope the code is also visible to all of you. Now let's start with the next step. So here, what we are doing. Now, let me mention the heading and all, everything I will mentioning over here. So, first of all, guys, what I will do, I will perform. So I have imported the library. Now I will explore the images and then I will transform the images. The first thing, the first thing is what? First I will explore the images and then I will transform the images. Transformation is required for what? Before the model training, so that I will get the general model. I'm not towards to the overfitting or the underfitting. So for that, basically we perform the best to best feature engineering or the transformation technique. Now here, the what I'm doing now, I am so let me mention inside the markdown. So here basically we are exploring the data. So exploring exploring the data, okay, or images. Anything you can say over here, images. So images, img, great. Now exploring the perfect. Now, if I'm going to run it, so here you will find out the heading. So here is my heading, exploring the data or images. Now, what I have written over here, let's try to understand step by step. I already written couple of code, so it's not going to be a very much difficult. It's like very, very easy. So by seeing the code only, by reading the line, you can understand. So here what I'm doing, so here is my class name. Now, if you will look into the data, so you will find out that we have two classes in the data. It's a binary classification problem. So we have two classes in the data. The first name is normal, and the second is what? Second is the infected, means pneumonia, right? So one is representing normal images, and the second is representing the person who is having pneumonia. Got it? Now let me run it and let me check the class name. So yes, we have assigned the class name. Now here, if you will read to this, if you will read now to this one, input and the output to this doc string actually. So the input directory location and the output directory location. So input is equal to input directory location, output means output directory location. Now what I'm doing, I'm going to segregate this code as well. So here I will just define the function. So let me keep this particular line over here. Now just try to read it, what I've written over here. So here we are taking a directory. We are taking a directory. Actually, my data is available inside this particular directory. So inside the data, actually, you can see we have test. Inside the test, we have two classes. In the train also, we have two classes, normal and pneumonia, normal and the pneumonia, right? Now, here actually we have two classes, normal and pneumonia, and inside this one, inside this folder, my data is available inside this pneumonia and this normal folder. And we have two folder, one is train and the second is test. Now what I want to do, I want to list all the directory name. Okay, I want to list actually all the file, whatever file is there inside the, whatever file is there inside the folder. I'm just checking the data. You know, no, you check inside the machine learning. So once you read the file with the csv, txt, json or whatever, then what you done on top of that, on top of the variable, after collecting a data in the form of data frame or anything, right, or array or whatever, what do, you call this head method. So after calling the head method, actually you are getting the top 5 rows, top like after running this tail, you are getting the last 5 rows, the sample, you are getting a random sample. Similarly like this only. So here as of now, I'm just going to listing all the data. That's it. I'm checking all the data, and then I will try to get the random data, random images from there. Just I want to explore the data. That's it. Okay. So whenever you are doing any sort of a EDA and all related to the image data, so try to follow this notebook, and you will get a good exposure. Okay, so you will understand that how to perform the EDA and all analytics and all on top of the image data, image based data. So here I'm listing all the images, whatever is there inside this dir. Now let me run it. Now here, how will we get the dir name? So let me show you. So this is the command. So first of all, let me execute it without the method, without passing into the argument. So here you can see we have the data path. I think you know the data path. Training folder is there, class name is there, and here like we have two class name, first and second. First is normal and the second is pneumonia. So once I will execute it, so here you will get that I am getting this normal. See, user, Sunny, deep learning, artifact, this is the date, data ingestion, data, train, and normal. I hope you are getting this thing, that what is happening over here. Now, what I will do, I will like list all the files and all. So over here, what I can do, I can run it. Now, file, file, list, normal, train. So let me show you what I will be getting inside this particular variable. So if I'm executing it, this file list normal variable, normal train. So see, I'm getting all the file basically, which whatever is there inside the folder, or whatever is there inside the folder. This one, this is all the jpg file, this is all the image file. Now like this I can execute any other cell. So class name is one is going for the what, for the pneumonia. So here actually I will get all the person who is having the pneumonia. Let me show you that. So first let me execute it. Okay, it is executing. Now here you can see we have a data related to the pneumonia. Now like this basically you can get the test value as well. So let me do one thing, let me execute this thing, and let me show you that what is happening. So here guys you can see if I'm running it now, file list normal test. So file list normal test. See, I am having all the images, the test images. Now here pneumonia. So if you want to check with the pneumonia, you can do that. So here is what? Here is the pneumonia one. Now the code is very easy for getting these images. Now code is very easy. You just need to write the function. Okay. And inside this function, we have already like a method only. So list directory is like a by default method, which you will find out inside the OS itself. You don't need to write it down any custom thing over here. So here you can see we are able to list all the files whatever is there inside the directory. I believe guys this thing is clear to all of you. If it is clear, then let me know. I will proceed with the next concept. And here you can check the length and all, then how many images and all we have inside the particular folder, because everything, every name we are getting in a list only. So simply we can call this length method on top of the list. Now here you can see if I'm running it, so you will get the numbers of the images. So in normal folder we have 105 okay, and in the training data, now we are talking about the testing data, so you'll find out 30 images, 30 normal and 30 pneumonia. I just kept the like very low data here, because otherwise I will face like so many issues regarding the training and all. It is going to take a lots of time, so that's why I just kept 105 images. But in real time the scenario might be different, you might get like 100 or 1000 or lakhs of images. So guys, be ready for that type of scenario. So here, this thing is clear, how to get the image and all. If it is clear, then please do let me know, guys. Fast. I'm waiting for your reply. Tell me, guys, if till here everything is fine. If you want to get a code where I have kept this code, you can directly get it from the GitHub only. So just go and check with the GitHub. Over the GitHub, I have already updated this code. Now inside the GitHub, where it is, just wait. So just go and check with the notebook here, and inside the notebook my experiment is available. So please try to like copy the code from here, guys. Please do it. I hope it is getting clear to all of you. See, I kept each and every code already in my GitHub. So if you don't know about it, if you are thinking that from where I have to like get this code, how I have to execute, no need to worry. I have like arranged everything for you. So please try to download it from the GitHub. I already like given you the link inside the chat. Okay, so it is getting clear. Now the next thing is what? Now here, can anyone tell me why we are writing this code? Why I have written this code? This one, the code basically which I am highlighting over here, this one. Tell me guys fast. Why I have written this code, this one. So this code is just for the visualization. Any random image you can pick from the data and you can visualize it. That's it, nothing else. It's like a very easy. So first of all, see what we are doing here. We are generating a random number. So what we are doing here, we are generating a random number. So between what? Between the 0 and the length of the images, the number of images actually. Because this images, if I've kept inside the list, so one by one actually I'm going to pick the images. So the list index is going to be start from the 0, right? 0. So that's why we have mentioned the 0 over here. So let's say we have 100 images. So what will be the index number for the 100 images? Tell me inside the list. 0 to 99, right? 0 to 99. So the list, let's say, is going to be from 0 to 100. So it's going to exclude the last number. It's going to be exclude the 100, and it will pick from 0 to 99 only, means 100 number in a sequence itself. Got in my point? What I'm saying here. If your Python fundamental is strong, then definitely you can understand this randit function. Now, or this range as well. So what I'm doing here now, let me execute it. So what I will get this rand image number. So here I can run it and I can check what will be my output. So see guys, I'm getting this 70, means I'm just going to visualize the like image, this single image here. Okay, just try to visualize this particular image. Let's see how we can do it. So already we have kept the path over here, and we are passing the number to this one. So just a second, let me run it. So this is what, this is my path, train path. In the train actually we have two folder, normal and the pneumonia. So here we are using this normal file list normal train. So file list normal train, right? Now here we are passing this. Here actually we are passing, what we are passing, tell me. We are passing the random number from where we are getting the file list normal train. So here itself we are getting it, file list normal train. Where it is, this one, file list normal. Where is a normal? Here is a normal, guys, this one, file list normal train. Because this list is what, this list is nothing, it's collecting a number, and the number, the list is going to be start from 0. So 0 to the length minus 1, right? So now what I'm doing here, just a second, mm, let me show you. Okay, image number is fine. Now here file list number. So what I can do here, I can just like do the slicing and all. So I just want to check the top 5 record. Okay, so see, I'm able to get top 5 record. This is the one. I'm going to check the random one only. So here I'm reading the image. This is what, this is my read method. Then I'm mapping it over here, mp image. I am mp image dot I'm read. We are passing image. Then finally we are showing the image. Okay, let me run it and you will find out the output. So see guys, here actually once I will run it. So here we are getting the output, this one. Now likewise, at in one time actually, okay, in one execution I will get only one image, because here the random number which you will see, so it is going to generate only single number, single random number, this one, where it is. So the random number, this one, if I will run it now, this one, see, you are just getting only single random number. Now again I am running it. So this time the image will be a different one, because we are using the random function. So every time it will generate the random number. So what I can do here, I can run it again, and let me take a random image. So random image number. Now let's see what I will be getting here. So I'm now, this time I'm getting 31. If I'm executing it now, you will see that the image is getting changed, right? Because the number, okay, okay, this one is there. Yeah, this one is there. Now let me check. So see guys, the image is going to be changed this time. The image is going to be changed. Every time actually it's going to be changed. Okay, so every time actually it is going to be changed, because it is generating a random number. So this is just for the visualization. This is just for the exploring the data. This is just for the visualization. If you want to visualize, or if you want to like get any sort of a image, you can get it by using this method. I hope this is clear to all of you. Then I will come to the next one, next particular step. The step is going to be a transforming images. So here what I'm doing now, I'm going to write it down here, trans for, okay, just wait guys, what is happening, this transforming the images, transforming, yeah, perfect. Now let me put the hash, and now let me run it. So here I am going to execute it, just a second. Yes, transforming the images. Is it visible to all of you? Tell me. RGB image came here actually we uploaded X-ray image. How? Please tell. Okay, locations are saying that we have uploaded the black and white images. Now, how this colorful images is coming? Because of this module, MP image. Because of this module, we are able to get it. If we are not going to use this module, we won't get the colorful images. So guys, I'm giving you 1 minute of time. Please try to execute it and try to reach till here, transforming the images. Do it, guys. So here we'll understand that how we can do the transformation and all. And then finally, I will come to the training part. So how we did training by using the PyTorch. Please do it, guys. Please do it. Try to copy it, and here we'll understand from this data transformation. Okay, so I believe everything is fine. Yeah, now it's time to do the transformation and all. So yeah, just allow me a minute. Great. So now, guys, what I can do, let's try to understand the transformation step. So what we are doing inside the transformation, even you can check with your modular component and all, right? So everything we have mentioned over there, but yeah, again, let me run it inside this experiment and all, inside this IPYNV and all, right? So you will get a clear cut idea. Transforming the images. So inside that, see, we have this transformer. Okay, transform basically. Now from here, from this transform, we are going to call this compose. So here we are defining the different values related to this resizing, okay, center crop, color jitter, okay, random horizontal, random rotation, then two tensor, normalize and all. Regarding each and everything, actually, we are going to regarding each and every like a attribute, we are defining some sort of a value. I hope you are getting what I'm trying to say over here. Now, guys, see. Here actually this transformation, why it is required. So first of all, let's try to understand that what we are doing over here. So here actually we are performing the augmentation, right? Here what we are doing, tell me, we are performing the augmentation. Now what is the augmentation? Data augmentation. So see, you know the camera, right? Actually you are I think you are looking to me, and like you can understand whatever I'm explaining you, whatever I'm like teaching you over here, just by seeing my face or just to listen by my voice only, because you are familiar with it, right? You are familiar with it. You already train your brain, your eyes, right? So that whenever I'm coming in front of you, you can understand. But let's say I'm training one model over here. Let's say I'm training one CNN model. Now this CNN model, right? So what I'm doing here, tell me, I'm just training one CNN model. Now the CNN model actually it has been trained in such a way that it just took this type of images where the person is like looking to the camera, right? Or the person are looking to the forward, right? So here, like this is this type of images we have. But guys, tell me, in real time it is not possible. In real time, actually, we are getting a data, so we can get any sort of images, any type of images, right? Any type of image we can get. What is the meaning of any type? So here, this person maybe is not looking over here, right? So he is not looking uh, to this camera. He's looking somewhere else. He's giving a candid pose, something like this, whatever. Or the images size over here. Let's say here we are talking about the image size. So let's say the image size over here, 24, 2 to 4 cross 2 to 4. Now, but let's say next time we did change, we changed something over here related to the camera functionality and all, and now I'm getting the bigger image size, let's say 512 cross 512, or maybe the like in a more definition, right, in the high definition. So that is the issue. So here actually we have to train our CNN model not with respect to the single pattern where I'm just looking into the camera or I'm just looking to the straightforward. No, not like that. We have to train our model in a generalized fashion so that whatever type of image we are giving, whether the person looking there or here or like behind or this side, that side, it can capture anything. Okay, with respect to any sort of a resolution, whether it's a high definition or like a standard one, anything. I hope you are getting this point. Now, why this is required? So yes, for generalization, actually, this documentation, this augmentation is required. For what? For the generalization. So model actually it's not going to be a overfit. It's not going to be a overfit because over the trained data, it's going to well work. Okay, it's going to work well actually. Why? Because it know actually where we are looking. We are looking into the camera and we are like this, straightforward. But in testing, let's say the data is coming like this, then in this case, model will be looking to my face and it is not trained on that particular scenario, and it will raise the error or it will decrease the quality of the model. So if you want to make a generalization inside the model, right, while I'm training the model, at that time we should use, at that time actually we should use this augmentation related to the image data. So I hope this thing is perfect to you. Now let me show you the code and the parameter and all. So here we have the different parameter. So transformation dot compose, resizing, center crop. Now here, if you will look into the import statement, so already we have imported this transformer. So where is the transformer? This one. In the torch, actually, it is already there. Getting my point, guys? In the torch module, it is already there. Here, your understanding is also correct. Now, here, here, uh, transformation is clear. Torch vision, actually, this torch vision is already having this transformer. Okay, transform, actually not transformer, transform. We are doing a transform over here, right? So we are defining a value. Now the different value you can see regarding the resizing and all. Now here, these are the values. These are the value. So regarding the training and the testing, more data, right? Now here, you can see. So first, let's look into the training data, training transformation. Just wait. Let me keep it over here. Just wait. So this is for the training. Just 2 seconds. Yes, it is working fine. Now see, this is for the testing. Now here in the training, actually, right? In the training, you will find out that we are using so many parameters compared to this testing. Why so? What is our logic behind it? Tell me. Because we are training the model. We want to capture each and every pattern. Getting my point? Now here, while we are doing a testing, so at the time of the testing, actually, right? So here, in the testing, just resizing is required. We want to resize the image. Let's say the image is coming in a different resolution. Here we just resizing it. That's it, right? We are normalizing it, and we are converting into a tensors. That's it. But at the time of the training, different thing is required, like rotation, okay, horizontal rotation, vertical rotation, right? So different parameter you can see, different color combination and all, and we have hundreds of parameter. Now training is fine, testing is fine. Now let me run it, and here guys, first of all let me show you the train data. So this is my train data, this one. So here let me show you the train data. See, I have trained data, this one. This is my train data. Okay, where it is available in the training folder, in this location. In this location my data is available, right? I hope you are getting it. I hope you are able to understand it. Now we can see the test data also, this one. test data. So let me show you the test data. Now here I have the test data, this one. So we have train data and we have test underscore data, test underscore data, right? So both data, and this is the location of the data, right? This is what, this is the location of the data. Now everything we are getting over here, like how many images is there, okay, and resizing, center top, two tensor, normalize, what all thing I have to perform. Why it is like this, tell me? Because here I am calling this inbuilt method, this image folder, right? So actually dataset dot image folder, dataset is there, and on top of this image folder, and here we are giving the path of the data, and this is the transformation attribute, this one, and everything is the inbuilt only, which I'm getting from the PyTorch. Now here see, we have this train data, and this is what, this is my test data, right? Now from where we are going to call this data, and this like a transformer and all, transformation and all. So already we have imported it over here in the import statement. If you don't know over here, guys, you can see, you can check, you can scroll up, and in the ipynb itself you'll find out this import statement, like data set, transforms, models and all. Getting my point, guys, here? So don't be confused, first try to check the entire code, and definitely you will get it. Now this is fine, this is clear. Now the next thing is what? So okay, images is there, transformation is happening. So first of all, let me run this test data, and this is going to be my train loader. So here you can see, now I am loading the train data at this particular step by step, guys. I am running it so that you won't confuse. I'm not running the single cell, the entire cell, and I written already the entire code, because it will save my time. I no need to write it down again and again. This thing already we have written inside our component. It's just like a quick recap or the walkthrough of the entire process. That's it. Now data loader is there. So data loader is there. Now train data is there, best size is there, shuffle true, and pim memory is true. Now this is what, this is my data loader, the object of the data loader. Now we are passing this train data, we are passing this train data to this method, to this data loader, and here we are passing this test data to this data loader method. Now what I can do here, I can copy this thing, test data loader, and I can keep it over here. So I have two data loader, first is train data loader, and sorry, first is train, first for the train data, and the second for the test data. Now if you want to know about this particular method and all, data loader and all, so simply you can search, right? So let me show you how you will search about it. Okay, so just go and check with the Google, with the documentation and all. Just open the Google, and here simply you can pass this thing, torch vision. Oh, just a second, let me take a correct import statement, this one. Just copy this thing, just copy this import statement and paste it over here, this one. Now you will find out this thing. Now directly you will see this particular thing over the, just a second, uh, from, it is from. Now directly you will find out this thing over the documentation only. So PyTorch 2.2 documentation, just check it, right? Just check it, torch utils data. Now here is what, here is a data loader. If you are getting confused, if you are not able to understand that from where it is coming and all, so guys, see, first of all you will have to check with the documentation. In documentation they have provided you each and everything, each and everything along with the parameter and all. Now these options are configured by the constructor argument of the data loader. So here the data loader is nothing, data loader is a class, and to this particular class we are passing this different parameter, right? So whenever the constructor is calling, right? So whenever the construction is calling of this data loader class, all the attributes, all the attribute is automatically is going to be initialized, all the attribute is automatically going to be initialized. Right here you can see this one, I hope it is visible. This with the white background also you are able to see this code, right? The white background also. Now data loader is there. Now data types, map style data types, iterable style data set. Now map style data set. Okay, different method and all you can export, and you can read the documentation, guys. You will get like a multiple options and all. But here this data loader for what, tell me? For loading the data, for loading the data from where, from the directory itself. Now here you can see, so like there is a different parameter, you can go and check and you can understand the meaning of it. So this is the entire class, right? And this is the description of it: data set, best size, shuffle, sampler, and this best sampler, num work. Now, if you are talking about this pin memory, so what is the meaning of this pin memory? I mentioned it over there. Tell me. So pin memory means, if true, the data loader will copy tensor into device pin memory before returning them. If your data elements are a custom type or your collect function return a badge that is a custom type, see the example below. So what it is saying, pin memory means what? If true, the data loader will copy tensor into device CUDA pin memory. Okay, so it will like pin into the memory, the like if we are running it by using this CUDA for what? For the GPUs. Okay, it's a library for the GPUs, right? For the graphical processing unit. If we are using GPU, then definitely we'll have to configure the CUDA, right? CUDA version inside the system, right? So I hope this thing is clear, the pin memory and all, and from where you will read the definition and all. I think each and everything I have shown you now, uh, it's not like very much difficult for you, and easily you can understand. If you have a basic idea of the PyTorch and all, definitely you can get it. Now, data loader combine a data set and sampler, provide an iterable over the given data set, right? So step by step, basically, we are doing a augmentation based on a given attribute, right? So here in a backend, actually, they have defined one iterable. Why it is there? Why iterable is there? For executing object to object. Okay, so image to image, single at a time, single image, right? We are executing that, and we are performing a transformation technique. It is loading a single image in a memory at a time. That is the use of the iterable. So if your Python concept is clear, definitely you can understand this type of function and method in a easiest way. Got it? Great. Now the next thing is what? So after defining this data loader and all, I hope this thing is clear. Now let's try to execute it and let's run it. So just a second. I'm getting images. Okay, this is perfect. This is perfect. Now let me run this data loader. Great. Now here, where is the one? Where is the next one? Okay, transformation is there. Train data is there. Okay, test data is there. Great. Now train data loader, this one. So I have executed. Now this is my test data loader. Now if I will run it, guys, so you will get the like number of images. How many images is there inside the train and inside the test? So inside the train, actually, we have total 210 image, and inside the test, we have 60 images. So I hope, guys, this thing is getting clear, how to exploring the image and all. Right now, if you want the detail of each and every, if you want detail of each and every like parameter, so yes, I kept that also for you, because I don't want to I don't want to leave you like this, so that like you will go and check with the documentation and the different resources. Everything let me keep over here itself inside this one notebook only. Just wait, let me copy and paste each and everything. So here is the one. Now just go through it with this particular like notebook, and you will get everything here. So this is the meaning of each and every attribute which we are using for the data augmentation. Now the next thing is what? So yes, data documentation is done. Now let me do one thing. Let me take few more things from my notebook, from my notepad. Actually, I already written it, and here this is the one. So you will get the meaning of this. Just okay. So here is creating data loader. So image folder and all, and here is data loader and all, everything basically I have defined. Now the next step is what? So here I'm going to create architecture. So just wait. Now let me create the model architecture as well. Just a second. Okay, great. Now here is for the model architecture. Now it's time to create a model architecture, and then I will show you that how you can create a model architecture by using the PyTorch. First of all, guys, tell me, so far everything is clear, everything is fine. We are about to complete it, and then we'll try to see the model evaluation, and the next class we'll see model pusher and all, and finally the deployment of it. Okay, so just a second, guys, let me check with my charger. Just allow me a minute. Wait. Yeah, perfect. Okay, great. So yeah, let's see how we can create an architecture of the CNN. So we are not going to use any like a pre-trained model. Here we are going to create architecture from scratch only. Now this is the entire description of the neural network architecture, sorry, convolution network architecture. First layer, then what we are doing, back spooling and all. I think you already know about it, but don't worry, I can give you some idea over here related to the CNN architecture, and then I will come to this coding part. And then after this architecture and all, we have the evaluation, first training and then evaluation, and then we'll try to write the code inside the model evaluation file. So let's try to understand the convolution neural networks. So what is the meaning of it? Let me give you the quick overview of it. Just a second. Now, if we are talking about the convolution neural network, guys, so there are various steps. Now, the first thing is what? So let's say we have a image over here. This is what? This is my image. Now, on top of the image, what I will do, so this is the image, and image is nothing. It's a pixel. It's a collection of pixel. Now, from this image, I will extract the feature. So I will multiply it with the feature. So let's say this is what? This is my feature. This is called my feature kernel, anything you can say. Now here this is going to my feature. Now image wise also, guys, see, this feature is also, this feature is nothing, it's a small matrix only. So this is not, this is my kernel, or this is my, let's say this is my feature. Okay, feature, anything you can say. Now I will multiply these two things, image and the feature, image and the kernel. Now this step is called the convolution. This is what? This is the convolution. Okay, this is called convolution, image convolution. Now here, once I will do that, so here I will get the image, right? So I will get the image, and this image is going to be a little small now, because here I have extracted the important feature by using this filter, by using this kernel, by using this filter, or by using this feature, anything you can say. So we perform the convolution, and the convolution, actually what I did, I extract the important feature, only important feature of the image, right? Whatever required feature, whatever feature basically I can extract by using this filter, I'm extracting those feature over here in this image. Getting my point? I'm extracting those feature over here in this image. Now what I will do, so here I will pass this image to the activation function, and here we use the ReLU. Okay, so why we use this activation function? Activation function actually we use for reshaping the values. Okay, so here actually if we are talking about the images, so the value can be anything, the value can be anything over here. Now here in the images, actually this is nothing, this matrix is nothing, it is having a specific value, pixel value, right? Pixel value. Now it can be anything, it can be anything after the multiplication and all. So it can be in minus, it can be in plus, or whatever, right? Because this filter actually it is containing, because see, if we are talking about this pixel value, so specifically the pixel value between will be between 0 to 255. Now here we are talking about the filter, so the filter can be anything. So let's say this is going to be a 1 1 1 0 0 0 minus 1 minus 1 minus 1, right? So here I don't want to keep the negative value, right? So here actually I don't want to keep the negative value inside this convoluted image. So what I'm doing, I'm passing to the ReLU method. I'm passing it to the ReLU method. Now, what is the meaning of the ReLU? So it will convert all the values, all the data between 0 to like, so whatever negative value is there, so it will convert into a 0, and all the positive value will be as it is. So something like this, this will be. So here, whatever like negative value is there, so positive value will be as it is, like this one, and negative value actually it will be 0 only, this one, something like this one. So this is the graph of the ReLU, okay, between 0 to or like a number, whatever is there. So here is nothing, it's the ReLU. Then after, what I will do, I will pass it to the max pooling, right? Max pooling, min pooling, anything, any type of pooling you can do. I'm not saying only max pooling, there are different type of pooling, mean pooling, average pooling and all, but generally we prefer to this max pooling for getting the dominant feature from the images, okay, from this convoluted image. Then after that, what I will do, I will convert the flattening. I'll do the flattening. So what is the meaning of the flattening? Tell me. So flattening is nothing. So I will convert my data into the 1D array. Okay, 1D array. And this image actually I will pass to the neural network, fully connected neural network. So fully connected neural network. So I will pass to the image to the fully connected neural network. So these are the steps we have from this image to this fully connection, and then I will pass the data to the fully connected from this fully connected layer, and finally I will get my output over here. What I will do, guys, what I will get, so after passing it from the fully connected network, I will get my output, and then I will perform the loss method over here, and then I will pass the I will like do the back propagation. There I am going to use the optimizers and all, right? Optimizers and all. Now in this one, in this particular architecture, you will find out that we have two type of parameter, right? Two type of learning parameter. The first learning parameter in terms of this kernel, right? The first parameter in terms of this kernel. Now the second parameter in terms of this fully connected neural network, right? So this is going to be my learning parameter. So whenever we are saying that we are running a multiple epochs, right? So whenever we are saying that we are running a multiple epochs, now see, this value actually it's a it's a learning parameter, means as many as time I will like run forward propagation or backward propagation, this value is going to be changed, right? And by using the optimizers and all different optimizers we can use, and this is called the complete CNN architecture. Now here, guys, if you are talking about this value, this is a kernel and it's a learning parameter. So every time in every epoch actually it's going to be changed, and my model will try to converge. Converge means it will come to the local minima. Okay, it will come to the local minima. It will try to find out the minimum value, minimum loss value, optimize this weight values, right? So that we can get the general model or the better model, right? So that's going to be a complete mechanism of the CNN. So here, this is my learning parameter, and this is going to be my learning parameter. Whatever weights and all we are going to assign a weight. So this weight actually is going to be my learning parameter, weight and biases also. This pooling, this one pooling actually, whenever we are doing a pooling on top of the 2 by 2 matrix, on top of the 3 by 3, right? So it's not going to be a learning parameter. This pooling is not my learning parameter. This is my learning parameter. I hope this thing is clear to all of you. Now let's try to code this architecture by using the PyTorch. So by using this PyTorch, what we can do, we can code this architecture. Let me show you how we can do it. So first of all, let me share my notebook, and I hope, guys, you are enjoying this learning. Now let me open my SDMI and see, guys. So this is the entire code. Let's try to run, or let's try to understand step by step. So if we want to create a convolution neural network or neural network inside the PyTorch, so here actually we'll have to like write each and everything inside this class. And here inside the class, whenever we are defining this class, this class basically, so we'll have to call, we'll have to mention this nn.module inside it. Now let me show you from where we are getting it, from where we are getting this particular class net. So this net actually we are like loading it from the PyTorch itself. Torch neural network functional. Okay, it's a functional speller. Torch. Just a second, guys. Let me show you from where we are going to get this net. PLT, MP image, display, TQDM. Just a wait, guys. So here inside this ML, let me open my machine learning module. This one inside this model, inside this archive. Yeah, so guys, here you can see class network. So already we have defined a class, but don't worry. Right now I'm showing you everything inside the IP1 file itself. So let's stick with this only. I think while doing a training and all in the previous session, Bapi has already explained you about it, but don't worry. Again, let me show you. So this is my class, guys. Class name is what? The class name is net, which I kept. Now neural network module. So this thing basically which I'm importing. I shown you now, right? So here, if you will look into the like import statement, so you will find out that I'm already imported this neural network. Okay, torch.nn as nn. Now what I'm doing after this one, after initializing this class, I'm going to create my architecture. Now inside the architecture, actually you will find out. So the first thing is what? So here, basically, the first thing is what I'm going to call the super method. Super method means what? So like whatever the whatever like parent class we have, right? So like regarding that parent class, we are going to call this init method. Okay, we are passing this net. We are passing this net to that init method. Okay. Now after that, guys, we are going to create a sequential pipeline. So the first thing is what? So here you can see convolution. So first, first step is called convolution, as I told you. Now here, what is the size of the convolution? So the kernel size, actually, the kernel size is 3 cross 3, right? Now here, you can see, so this is the channel in the green, in the if we have a colorful image, inside that we'll be having three channels, right? R, G, and B. So you can see there is a three channel. Now this is the output channels, right? So total 8 channels basically I will be getting after multiplying this particular kernel. So 3 cross 3, and inside that basically we have three channels, right? Now RGB is going to be convolute with R, G, and B, right? Because in this in the like colorful image, actually we have three channel. One is R, the second is G, and the third is B. Now after that, see, padding is 0, bias is true, right? So then we are applying the ReLU and we are applying the normalization also over here. Then max pooling, okay, then max pooling. Now here is my convolution block 2. So after this one, guys, we are going to apply, we are going to create one more convolution. We can do it as many as convolution block we can create. So here in this particular architecture, let me show you the architecture. This one, this was the architecture. In this architecture, after this max pooling, after performing this pooling, actually we can do convolution one more time. It's not like that I have to create the, I have to do the flattening, means I have to convert my array into the 1D array, and then only, and then basically I'm going to pass to the fully corrected neural network. No, it's not like that, right? So as many as time we can repeat it, right? We can use the like so many kernels, so many poolings and all. It is fine until we are not getting a optimized one, the optimized value, right? And this is based on an experiment. And it's not like that this is the number, okay, you have to try only 10 times, 15 times. No, it's not like that. It completely experiment based on a data. If you understand about your data, definitely you can understand that how to like create the custom CNN and all. For that, actually you can read about few trained CNN. So like BGG, ResNet, Inception, DenseNet, okay, NestNet. There are so many neural network, so many convolution neural network which has already trained. You can go and check with the like internet, different type of neural network, convolution neural network. And by seeing those neural network, by seeing the like research paper and all, right? So which data they have used, what was the type of the data, okay, and how many filters and all they have used, you can design your own network as well. So here, just for the demonstration, we are creating a simple network, and then like it's up to you whether you are using those pre-trained network or you are creating your own network based on a experiments. I hope this thing is clear. Now coming to the file. So in the file, basically what I can do, in the file itself, so we have the convolution, the second convolution, then pooling here, and then here is nothing, it's a sequential. Basically we are going to connect each and everything. Then block 2 is done. Now block 4, block 5. So we have created 5 convolution layer, and sorry, 6, 1, 7, right, 8, and here you can see everything. Basically we are going to be like connect with each other, right, by using this sequential. Then after, this is the feed forward neural network, means after collecting the data, so after like extracting the feature, so we are passing it to the neural network. At the end, we are converting each and everything in a one dimension array, and we are passing it to the feed forward neural network. So this is the method for the feed forward neural network, this one. And then basically what we are doing, so we are passing it, means all the we are passing all the convolution layer over here, and we are doing a single array, and then we are passing to the like a neural network itself. Now here, this is fine. So we are using this we are using the software function at the end, and then here you can see what we are doing. So we are going to check the summary of the model. Now let's do one thing. First of all, let me run it, this particular part, and after this one, let me run this part, and let me show you the summary, that what will be the summary. So this is going to be a complete summary. You can read everything over here inside this summary itself. So in the summary, actually you can see this is the shape of the image, right? Output shape 222 222, right? This is the number of parameter. Now here we are applying the ReLU and then batch norm, then max pooling, then you can see convolution 2D, then convolution 2D, right? So three times, and here you can see like multiple times we have done the convolution and all. Now till here, this is the convolution. Now here you can see forward and backward pass size. So 17 MB is the forward and backward pass. Now this 70 MB actually it is based on the trainable parameter. So trainable parameter, where is the trainable parameter, guys? In the kernel and in the feed forward layer, right? In the neural network. So let me show you the architecture one more time so that you will get the clear cut idea. This one, guys. So this at this place, actually this one here we are having the learning parameter. So here actually in the feed forward neural network we have the learning parameter, weight and biases. So this memory which you are seeing over here, this particular memory, right? This particular memory, the memory, this 17.64. So an estimated size, okay, parameter size, this one. So estimated size around 18.26. So it is based on that parameter. So if you are saying now like GPT model or some like a huge model which is having this much of parameter, that much of size, because of this learning parameter only, it's a weight and it's the size of this learning parameter. Now this is fine. Now here we have defined like couple of list and all. Now let me take this particular list and let me keep it inside the new cell. Just a second, let me keep it over here. So here, guys, you can see training loss, train accuracy, testing accuracy. We are keeping everything in the inside this list only. So here I'm going to run it. Here I'm going to execute it. And after this one, just a second. Now here I'm going to train my model. So this is the method which I have written for the training. So model, device, train loader, optimizer, epochs, and all, everything we are passing to it. So model.train, we are calling this method. This TQ at DM is nothing. Actually, it is for the progress bar. This one. Now correct, proceed. So we are going to initialize this value with a 0. Now data and target. So we are passing everything, right? Now here optimizer. So this is my optimizer name. And here I am getting my prediction. This is my loss, right? And we are going to append inside the list. That's it. Now guys, let me run it and then you will be getting it that what is happening over here. So first of all, let me segregate this training part. So here what I'm going to do, I'm going to segregate this training part, and here you can see this is my testing. So first let me run this training, and here is what, here is my testing, this one. Okay, now training is fine, testing is fine. Testing means what? On the test data. Okay, so on the validator, like on the validation folder, on the testing folder, right? So with respect to that, actually we want to check the accuracies and all, and that comes inside the evaluation part. Now here you can see, so we have the training and the testing. So first of all, let me run it, and training is fine, testing is fine. Then guys, this is my model. So now we are going to create an object, and here we are passing a device, means where you are running it. If you are running it to the, like if you are running to the GPU, then for that there is a different condition. If you are running to the CPU, then for that there is a different condition. So first of all, let me show you with respect to the like a CPU or GPU basically. So here you can see, if CUDA is available, then we are using the GPU, use CUDA. Otherwise, use the CPU. If you have done the CUDA configuration related to your GPU and all, then I will use the CUDA over here. Otherwise, I will use the CPU. Right now, what I'm doing here. So this is perfect. This is fine. Now, first of all, let me show you the training part, and then I will come to the evaluation. And the evaluation is going to be a final stage, and then I will give you the quick revision, and finally, we'll keep the code inside the model evaluation. Right now here you can see, so here we are going to create a like a object of it, object of the net. Then here is what, here is my like optimizer, this one, along with the learning rate and momentum and all. You can check the formula of this SGT, stochastic gradient descent. And then we have this step LR, right? So this is what, this is my scheduler. Now here what I'm doing, now here how many epoch we are running, we are running only one epoch, only single epoch. Now let me keep it over here inside this cell, and okay, it is perfect, it is fine. Now first of all, guys, what I can do, I can execute this part. So first test train is fine. Okay, let me run and let me execute this test also. Just a second. Okay, test is fine. Now let me execute this training model. So just wait, let me execute this training model. So our training will be started. So here is my training module. Mm-hmm. Okay, model is this one, epoch is this one. Now let me execute this one. Okay, great. Now here you can see, guys, once I run it, so my training is happening now. Okay, here. So here is number of epochs, how many epochs you are running. I'm just running a single epoch because uh, it will take too much time if I'm running a multiple epoch on top of the image data. I hope this thing is getting clear, guys. I know if you are it is not possible to write it down in the live class. It's going to be too much like confusing and all, right? And that's why I've written this code inside the IP1B file. I'm just executing in front of you along with the explanation. Once you will run it, automatically you will get it. So after running it, here you can see, so here is my first epoch, this is my loss, this is my batch ID, accuracy is this much. Now 105 is the total number of images, this is the learning rate. Okay, this is the average loss, and this is the accuracy related to the training, related to the training. Now here you can see, so now what I'm doing over here. So first of all, let me segregate this particular code, or let me show you the like training loss, training load, testing loss. Okay, model is here. Now here is print. Yes, test model, guys. So training is this one, and testing is this one. So testing also we are doing over here. Now what I can do, because test already I have defined now, so I'm just calling it over here. Now what I'm doing, so first of all, guys, what I can do here, let me take this code and let me keep it over there after this one, because it is going to be a confused little one. Okay, perfect. Now yes, it is perfect. Now let me delete it. Mm, okay, this is perfect. Now everything is fine, and let me show you. So see, guys, I will get the graphs and all, every graphs related to the training, testing and all. So this is my training loss, this is my test loss, right? So here is my training accuracy and the testing accuracy. So what I can do, just a second, I think this test was not working. Let me run it again. Okay, this is fine, this is fine. Okay, and this is fine. Training is happening. I hope I have initialized the empty list also. Where is the empty list? This one is the empty list. Mm, perfect. Now let me run it. Yeah, so see, guys, this is my training loss and the testing loss. Both are coming. So you can see related to the training and the testing accuracy and loss. And here is my training, and here is my testing accuracy, this one. And here is my testing training accuracy and the testing accuracy. Okay, so it's going to be increase as a straight line. Now here why it is happening, because the data is little smaller. I think we just have 30 to 40 images because of that. Now what I can do here, guys, I can give you the quick recap of it, quick overview, and then we'll start with the model evaluation. Model evaluation I already kept inside this component basically. So let me show you where it is. Testing, where is a x-ray, here is a x-ray, here is a component, and inside this is my model evaluation. Now, inside the model evaluation, guys, what we are doing, so we are just going to evaluate the model based on the test data, whatever images we have inside the test folder. On top of this one, we are just like evaluating the model, means we are just validating it. So here on top of this terminal itself, you will get the final answer that, okay, it's going to be average accuracy, or it's going to be average loss, something like this. So likewise, I have written a code over here inside this model evaluation. Now, one thing, guys, let me give you the quick recap of it, and then I will come to this model evaluation. So if you don't have this code, guys, please try to check with my GitHub. I already updated over here. Now let me complete this part, and then in the next class, we'll start with the different concept. So first of all, guys, this is all the libraries. Now, one more thing, if you want to know about the different import statement and all, so directly check with the documentation. Let's say I can give you one more example. I shown you with this data loader class. Now if you want to check with this step lr, that what is the meaning of this step lr. So already they have defined a class, they have written the complete class inside the documentation. You just need to check it over here, right? So just go and check with your documentation. just copy and paste it over here. And here guys, you will find out the documentation link. The very first link, it's a documentation link only. So instead of going here and there, directly you can check with this class. It is similar to scikit-learn only. I think you know about the scikit-learn if you have learned the machine learning. So inside that we have a class and the like a different parameter. So just read the definition of the class, just read the like a different parameter and modify it and use according to you. Now let's check with a different one. So here what I can do, I can take the different like a class. So let's say step lr is here, or what I can do, I can take this. Model is fine to all of you. Functional is okay. Let me take this functional over here, and you will find out that it is all about the functional architecture of the convolution neural network. So let me paste it over here. It is a function. It is not this one. Just a second. Okay, function is here. This one. So see guys, convolution 1D, 2D, 3D, convolution transpose 1D, transpose 2D, a different type of convolution is there. So everything you will get it over here related to this functional, right? Related to this functional API. This is called functional API. Now, I hope this is clear. Now you can read about this step LR. What is the meaning of it? So take the learning rate of each parameter grouped by gamma every step size epoch. Notice that such decay can help simultaneously with other changes to the learning rate from outside this scheduler. Okay, so actually it's a like it is directly related to the learning rate only. Whatever this optimizer we are using. So you can read about it. You can read in more detailed way. And here they have given you the uh, like code snippet also. So optimizer is there, and related to that there is a different parameter. So you can set the different value of the learning rate and all over here by using this step lr, and many more thing is there. So yes, definitely you can take a help from the documentation only. Now, next thing. So after this document, after this import statement and all, I hope data reading and all everything is clear to all of you. Now the next thing is we have collected the data. After this one, what we are doing, guys? Tell me. So after this one, we are applying the transformation on top of it. So first we are checking the random image from the data itself. Now after taking a random image from the data, what we are doing, we are applying the transformation. So here you can read the complete detail of the transformation, that what we are doing. So now that we have seen the sample of the data, we need to perform transformation. Complete detail I have written over here, so don't worry, I will give it to you. I will push the changes to my GitHub. Then this is the different parameter like resizing, center crop, color jitter, random horizon flip and all, right? So you can go through and check with the different parameter, then what is the meaning of it, what we are doing over here related to each and every parameter if we want to do a transformation related to the particular image. Now here guys, you can see train transformation dot compose. So this is the simple method which we are calling. And guys, again I'm saying this is related to the documentation itself. I haven't written by myself this particular logic. It's a predefined method itself, and directly you can check in a documentation only. So once you will write this PyTorch transform, automatically will get the documentation and this method and all. Okay, then similarly actually you can write it down here, the different value and the other parameter related to that particular different value related to that particular parameter. Okay, so I hope this is clear. This training is fine. And here related to the testing, so at the time of the testing only normalization and the resizing is required, so that's why we are doing it. Okay, over here. Now creating a data loader. So we are creating a data loader over here. After this data loader, what we are doing, everything we are combining all together. This like a different parameter, okay, different attribute, right? This one, and what, and the data. So everything we are combining over here by using this method, this data loader. So first we have train data, and then we have a test data. Now this is what, this is my data loader. So this train data and this batch size, shuffle memory and all. So everything what we are doing, we are combining, right? We are passing the data and we are passing the like those augmented parameter, right, for the augmentation and all. Now here is what train data classes and all. So this is my meta information which I'm able to collect from here after like reading the data and all, or after performing the transformation and all, right? So transformation is filed. Now this is the neural network creation. So how we can create a neural network? So let's try to understand. So first of all, try to read this particular definition, whatever I have written over here, just for you. So the definition is, first layer is input layer consisting three input channel. Means in RGB image there will be a three images, three channels actually in one image, right? And in black and white we just have one channel where we have a pixel. Okay, so whether it will be a 0 or 255 in the like black and white. If we are talking about RGB, so it will be between 0 to 255, and it's a combination. This color image actually it's a combination of R channel, B channel, blue channel, and the green channel, right? So three channel. Now and output channel with kernel size of 33. Now here padding 0 and bias is equal to 2. The activation function we are using in ReLU and performing batch normalization. Batch normalization means what? It's a normalization only. Means to perform the fast training, for performing the fast training, actually we use this batch normalization. Batch wise actually we are doing a normalization, right? Normalization is nothing, it's a kind of scaling of the like value, that's it. Now then we are performing max pooling. So max pooling is there. Similarly we are passing model through 9 convolution layer. As I told you, as I told you that uh, like we can have a multiple stack. So first we are doing a convolution, then max pooling. On top of that, another stack, another convolution, and all. Multiple times we can do it. And if you will look into the different architecture of the CNN, so let me show you where you will find out. So you can simply search with the Keras. So Keras CNN architecture. Keras. Okay, let me write it down here. Keras. So just wait, guys. Why it is not working? Keras CNN architecture. So here you can see we have the different architecture of the CNN. Oh, the sequence and all. Just wait, guys. Hmm. Or directly you can check with the TensorFlow also, because now this Keras and TensorFlow is same. So convolution neural network VGG Keras. Okay, let me search here VGG. Yeah, guys. So see this many architectures. So we have this exception VGG19, right? So here we have VGG16, RESTnet, or Inception, DenseNet, MobileNet, NestNet, EfficientNet, several architecture. You can read the research paper about this architecture and you can build your own architecture. It's YOLO and all, right? So it is having some other mechanism on top of this architecture only. So yes, YOLO for the object detection, it's a very efficient one. YOLO V8, V7, and it is using the same concept, CNN only, but in a different manner, in a different way. Means there are some other thing, and for the evaluation also, like there are some other concept like ROI and all, right? Everything comes into the picture. So I believe this is clear. So fine, I think guys now you can build your neural network. So let me give you one quick walkthrough of it. So here is my class, network class. Now see inside this architecture.py also we have defined the same class. Now we are importing this neural network. So we have imported this neural network, you can see. And after that, guys, what we are doing, we are calling a super method. So super means we are calling the like init method of the parent class, right? We are we are initializing that. So we are initializing that particular like a class. Okay, and after that, guys, here is you can see this is my first block. This is my first block. Now here you can see. So this is my second block. Okay, and here is my third block. Then I have fourth block. Okay, multiple times we have. Now here is my fifth block. Now sixth block. Okay, seventh block, eighth block, and nine block. Total how many block? Nine block. Now after that we are doing a pooling, and finally what we are doing, we are creating a feed forward neural network. Now here, guys, while we are doing feed forward neural network, we are using this convolution block, X, pooling, and all, right? So you know what is this? Actually, this is the functional API, this one. So functionally, so functional API, in sequential, actually, one by one, actually, we pass each and everything. So here, if you will look into this one, sequential, so we are calling, in with respect to this convolution, actually, we are calling this sequential. So we have this convolution 2D, ReLU, and batch normalization. This three thing will be in a sequence only. Now here, after this one, so what we are doing, we are connecting each and everything to each other. Okay, we are means convolution 1 with convolution 2, convolution 2 with convolution 3, convolution 3 with convolution 4. In every convolution you can see we have a multiple thing. So see, this is my first convolution, we are calling this sequential, and we have this 2D ReLU and batch normalization. In first block, second block, third block, in every block sequentially we are defining that. Now we are connecting all the blocks, okay, all the convolution blocks all together over here, this one, right? So this is my first block, third block, fifth block, and this is my ninth block, this one. And here is my output of that, right? Nine. Okay, so I hope this is clear. Now what we are doing, so this is my some like configuration and all, right? Which device and all we are going to use. So if I'm going to run it, so here you will see that the complete summary of the model regarding the each and every block, okay, regarding the each and every convolution. And finally, this is my training and all. Now we are doing a training. So we are calling this train model, and here guys we are selecting a device, so on which one we want to run it. As of now we are running on a CPU itself. And finally, this is my prediction and loss and all we are going to calculate. So everything you will find out inside this train and test, okay, this one. Now once you will read it by yourself, you will be getting it. And finally, see, we are running it, we are running this particular class, and we are deciding the like learning rate and all over here by you calling this step LR and all. And here is what, here is my training. Finally we are doing a training after defining all the configuration and all, and this is my graph related to the training and testing. So I believe you understood that how we have evaluated the model and how we have trained it. Now everything we have kept inside the pipeline itself. So this was the learning, or this was the implementation which we have done so far. So in two first and second class, I explain you the complete architecture. In third and fourth class, we have explained you about the transformation and the transformation of and the training part. Now here guys you can see, so if you will go inside the component, so inside the component itself we have this evaluation. So already I have written a code inside the evaluation. Now inside the notebook also I have explained you the concept of the evaluation. So what I want guys, so please try to check by yourself in the next class. What I will do, I will start from there itself, from the evaluation only. See, test net and train net. Okay, it's a okay test net only we have, because training already we have done. And this is what, this is my model inside the artifact, and inside this model training you can find out this model.pt, right? So model.pt is there. Now what you can do guys, so you can check with this experiment.ipynb. You can read about this like testing and all, this method which we have defined, and you can match it with the model evaluation. Already I have given you the code, you just need to check it that what we are doing. We are just reading a data. Let me give you the quick walkthrough of it. And yes, I'm not writing a code from scratch. So first is what, the first thing which we have to do, we have to write the artifact and the configuration. Okay, and from model artifact what we are getting a model itself, because for the evaluation model is required na. Whatever model we have trained, on top of this one only will do the evaluation na? Regarding that model only will perform the evaluation. So here the module is required, so model artifact is required, our model evaluation artifact and configuration is required, these two things. Then what we are doing, we are creating a object of this thing, right? So this okay, this is what, so here is self, okay, data transformation, data model evaluation, model trainer. Now guys we are going to initialize it, this thing, this particular value, self.data transformation artifact, model evaluation config, and this model trainer config. Now what I will do, so from where we are getting it guys, tell me. Already we have written inside the training one. Okay, I will show you that, I will come into that. Now configuration I have defined inside the configuration, and entity sorry, artifact I have defined inside the artifact file. And inside the training actually I have written each and every object and all that directly we are passing it over here, this one. As soon as I will call this, I will create an object of this model evaluation, I will get this particular value from where, from the training itself. Now from the training file, okay, now we have initialized it. Now here you can see we are going to configure data loader, module, float, optimizer and all, because for the testing actually it is required now. And then we are going to call this model.eval. Okay, then here a dev test. So inside this one actually we are loading a data. So this is my data, this is my label, okay, outputs and all, everything. And we are going to test it on each and every image. And finally we are keeping it inside the accuracy, and then we are returning this accuracy. And everything basically we are running from this initiate model evaluation. Now where we have defined it, guys, so this thing, this particular method I have defined inside this, tell me, this initiate model evaluation, this method I have defined inside this training, right? So let me show you the pipeline, training pipeline. And inside the training pipeline you can see, so this is the evaluation. So here we are creating an object, uh, object of the model. Okay, where is this? See, this is the this is the model evaluation, and this is the thing basically which we are passing: data transformation artifact, data evaluation config, and model trainer artifact. This three thing. Okay, this three thing we are passing over here. And from where we are getting it, guys, tell me. So if you will look into the training pipeline, so already we are like creating this like already we have created an object of this config, right? Model evaluation config, this one, this is the one, right? And from where we are getting the artifact, so model evaluation artifact. So this is the already we have defined this model evaluation artifact inside this entity folder. So here inside this artifact entity, see, model evaluation artifact, and here we have this model accuracy. In this one means my final answer will be what? Model accuracy, the output of it. Here inside the config entity, so model evaluation artifact, this is the values. So this is what? This is the configuration of it. So where we have created an object of it, model evaluation config, tell me. So inside the pipeline itself, inside the training pipeline itself, you can see here we are going to create an object of it. So data ingestion, data transformation, data trainer, and model evaluation. So here this is the object of the model evaluation, this one, right? Now once I created an object, I can call any method, or I can take any sort of a attribute and parameter. Okay, so here you will find out this inside this start evaluation. So once I will call this one start evaluation, so I'm passing what I'm passing, guys, here in this one start evaluation. I'm passing this model trainer artifact and this data transformation artifact, right? This two thing. So inside this, in this model evaluation, now from where I'm calling this one, so this thing I'm calling from this run pipeline. So data ingestion, data transformation, model trainer, and this model evaluation artifact. See, so here actually what we are doing, this is what? This is my model evaluation artifact. Actually, I'm now like calling it to calling this one start model evaluation here itself. This one, see, start model evaluation, and this is the thing. One is model trainer artifact, and one is data transformation artifact. This two thing actually we are passing it because it is required it now. First we'll have to transform the data, and then only I will predict it by using the model. So from here we are calling it. So this is the entry point, this start model evaluation. From here it is going to be start. So we are passing this model trainer artifact, means we are getting the model, and we are getting the model object, okay, transformation object from here itself. And this is the object and all which we are creating over here, right? Then this is my model evaluation class. And where I have defined this model evaluation, tell me, this model evaluation I have defined over here, the main one, this one. So like there is a complete like testing and all which is happening. So initiate model evaluation, we are passing each and everything over here, and this is my like model loading and all, everything is happening over here. So from data loading to model loading and the prediction and all, right? So likewise we have connected each and everything over here. So we'll start from here itself, from the model evaluation. As of now, for this session only, you just need to uh, practice with the notebook only. So just go and check with the notebook, just try to practice with the notebook. In the next class, come to the model evaluation, and I will keep the I will sync up all the thing basically, right? So with this model pusher, because this is going to be a little important. And if you want, then definitely I will write it down in the live class only. But the project is like a little huge, so it is not possible to write it down each and everything in a live class. We have already coded few things, but definitely I will try it in the next class, so that I will show you that how we are using this band to ml and all for pushing the model or for serving the model as a endpoint url. So here model evaluation, you can check by yourself. Other again I'm saying, if you are facing difficulty while you are understanding this part, so don't worry. Again in the next class I will start from here. This class is just for the notebook only, so that you can understand the entire flow till the model like a training and the evaluation. I kept the evaluation also in your GitHub, you can go and check. But yeah, this model pusher is not here. So model pusher part actually it will come after some time, means after completing this evaluation and all. And even see, if you will run this thing now, training pipeline. So let me show you one thing. This code is working fine. Okay, there is no such error. Basically, I have checked. If you have a data, if you have connected your like this local host with the S3, if you have configured your AWS after downloading this AWS CLI, definitely you can execute this code. So let me show you how you will execute this code. For that, you just need to copy this training pipeline. Let me copy this path, or here I've created one endpoint, this main.py. So let me copy this path and here, or let me copy the relative path. Now here what I'm doing, I'm writing this Python main.py. So just a wait, let me write this Python main.py. Now see, if I will run it, guys, so first it is going to fetch the data from the S3 and it will keep inside the artifact folder as the output of the data ingestion, and then it will execute the further thing. So see, guys, it is fetching a data, all the data basically I'm getting from the S3, and it is keeping inside the artifact folder. Okay, so just wait, it is doing. Now see, guys, the training is happening. It is doing a training. So training accuracy and the testing accuracy, basically training accuracy, we are getting it over here. It's not a testing accuracy. Now here you can see this is the evaluation part, this test set. So this is the training accuracy which you are getting over here, and this is the evaluation part, this one. So average loss is this much, average accuracy is this much regarding the testing data. So this pipeline is working fine. There is not an issue with this pipeline. But here as a homework, what you need to do, you need to like practice with the notebook basically which I provided you, and you need to go through with the evaluation one. Now in the next class, we'll see that how we can serve this particular pipeline. Okay. Model evaluation means evaluation of model function. Is it which model you are? So model evaluation means we have trained the model. Now let me tell you, let me explain you this particular concept. What is the meaning of it? So if we are talking about the model evaluation, see, first what I did, I trained my model. Okay. After training the model training, I kept it somewhere. I kept it somewhere. Let's say after training the model, this is the place where I have saved my model. So this is what, this is my model. Now I want to check the model. I want to check this model. So this is pt model.pt. Pt means what? Pt means PyTorch, right? PyTorch, this one. So pt means what? PyTorch. Now here, guys, if you will look into this pt, so this is what, this is my model. Now I want to evaluate this model. I want to check that. I want to validate it. So here I kept my data inside this test folder. Okay, I kept my test data. So here my test data is available in this folder. Now what I will do, I will pass this test data to this model, and I will check like what is the accuracy, what is the accuracy of the model, and what is the error, what is the error, right? So on top of the trained data, on top of the training data, on top of this training data, I have trained my model. So here is what, here is my training data. On top of it, I have trained my model. Now here is what, here is my model, and then the test data is coming, and on top of this test data, I'm evaluating my model. So directly I can check the accuracy and the error. Getting my point? Yes or no? I think yes. So this test data, actually it's having the data along with the label, right? So let's say this is my images normal, and one person is a normal, and the second person is having pneumonia, right? Whatever. So this second and normal, it is already having a label. Now my model, what it will do, guys, tell me. It will predict whenever we are passing the image, it will predict. So what we can do, we can check the difference between this prediction and this like original value, and with that we can check that we can check this accuracy and the error. I hope now this thing is clear to all of you who was asking this question. Now I am getting this error while trying to fetch my data from S3. I think, Vineet, you need to check with this S3 operation. Maybe you have written a wrong command. That's why you are getting this error. So please do one thing. Just try to go and check with my repository. Inside the repository, just do one thing here. Just click on this. Where is the repository? The repository. Just do one thing. Just go and check with the X-ray. And inside the X-ray, there is a cloud storage. Just click on this cloud storage and open this S3. Right now, inside this S3. So wait, let me show you. Inside this S3, now what you need to do. Oh, yeah. So here, what you need to do now, just copy this entire code. Just copy the entire class. Just copy this entire class. Getting my point beneath? Yes or no? Just copy this entire class and keep it inside your code and then run it. Then definitely you will be able to run it. Definitely you will be executed. Maybe you have written this wrong command. This argument and all, na? if you're getting a issue related to this path and argument because of this particular command. Just check with it, this command and this command. Okay. So fine, guys. I think it is already 4:30. Now we can conclude the session. So thank you guys for joining this session. Now we'll connect on Monday to Friday. There we are going to conclude this project along with various things. Now, please try to practice with this neural network creation and all by using the PyTorch. Try to explore more and more about the PyTorch. And guys, believe me, this thing is being used in the industry in the real time. I talked with many people. They are already working with a PyTorch with respect to this convolution neural network or this recurrent neural network, and it's going to be a really important. So it's just a glimpse. In 2 hours, actually, I can just like we can just explore this much of thing. But don't worry, in our next class, I will try to like I will tell you like so many other thing as well, right? Along with the different component and the different like a part of the pipeline and all, right? So yeah, thank you guys. Thank you very much for joining the session. Thank you. Bye bye. Take care. Have a great day ahead. We'll meet on Monday at same time at 2 o'clock. So thank you. Bye bye. Take care. And where you will find out this video. This video is available on the YouTube and in the same dashboard. So let me check with the dashboard now. I think the video is there. So here I can show you. Just wait. This is the dashboard, deep learning essential. Now go to the course, and here guys, see now videos is available. So you will find out all the video along with the resources and the quizzes assignment and all. Now just check with the description, dashboard link is there. Just try to enroll yourself and get the videos and the resources. And thank you guys. So thank you for joining this session. Bye bye, take care. We'll meet in the next class. Until, thank you.